Okay, thanks, Vanessa. For those of you that have been into our plant over the last year and a half or so, we have something called a Fab Forum, and what we're about to present is an extension of the Fab Forum. So if you've been here live, some of this is going to look very familiar. For those of you that have been here, hopefully, if you're online, you're bringing somebody with you so that they can take a look at the same thing that you saw. The special tooling topic of the seminar tends to be a popular portion of it. That's why we brought it to the web. And what I'm really hoping to do is, you know, not everything that you see in a seminar is golden. So hopefully something that you see, though, it inspires some sort of thought and something that you can use in your shop. So we'll move on here. Okay, and the seminar will be basically just broken into two very simple pieces. The first being, why would you buy a special tool? Something's going to drive you to buy that. And then we'll just go through some of the common tools. We've got 11 different categories that will show you a couple tools, maybe identify when to buy something like that or use something, and then some videos to support each one of those topics. Okay, and within the seminar, we ask a few questions. Some of this is for our purpose, but we'd like to know why would you ever go and buy a press brake tool? Before I start talking, what are your thoughts right now? So if you want to pick either 1, 2, or 3, you can only select one, but what's your, you know, all of these might be driving forces, but you know, do you buy a special because of the volume that you have and the efficiency you'll gain from the tool? Is it an ergonomic thing? Is it something to do with the part handling? Or would it be part finish in your case? So if you could select one of those, pretty easy question to answer, and we'll move on.
Got about 5 seconds left. You can get your answers in here, and then we'll share the results with you.
Okay. And it looks like volume and efficiency. That'd be a pretty good guess. Unless you're bending stainless all day, maybe that part finish isn't the most important thing, or ergonomics. You can usually find a way to do it, so you don't have to worry about that. But volume and efficiency, and that's what I would have predicted. So thanks for confirming that. But why spend the money on a press brake tool? You're going to reduce material handling, less bends and rotations, controlling whip up, large sheet forming. You can relate to all those things. Potentially, you've made some tools yourself. Radius tools are real common to make, and they might not have the accuracy or the durability that you're looking for. So you'll go and maybe get a tool that's heat treated, give you better life and repeatability out of the tool. Maybe the cosmetic finish, that's certainly in there. If you're radius bending or bending stainless or aluminums, you're going to probably want to have a nice finish, and standard tooling may or may not be giving you that. And you may buy something just because of the size of the tool. Maybe you want it to be all one piece. You're using, even in the precision world, there are applications where you'd rather have a long tool, the length of the brake or whatever. So maybe you'll want that special to be just a different height or length. And of course, each time you go to spend money, I won't get into how to calculate an ROI. I think everybody might have a little bit different way of doing that. But of course, there has to be a return on the investment in some way. You know, either in the tooling setup or the bend time. And if you can you make less effort and have a lot of benefit, you'll probably be able to justify that tool. So moving right into some of the different tool types that you might look at. A channel tool will be really common. You want to make 2 bends at the same time. So 2 bends at the same time, you can increase your productivity. Instead of 2 strokes, you have 1 stroke. You'll get dimensional consistency out of it. It'll come down and it'll hit in the same place every single time, basically on 1 gauging point, rather than introducing 2 different gauging points. You can integrate the back gauge. So potentially you could have a short flange, and you might want to integrate that back gauge or a hard stop so that you're not using the press brake as a gauging point. And you might have some holes or slots that deform, so you can control that forming rather than dragging it over a shoulder of a die. You can have more of a wiping action. So we've got a couple of videos here, and the first one that you're going to see will be You know what, let me just check. You're gonna see this is thicker material, what you're gonna see here. And obviously, more than one part's being made at a time. If these are small parts like this, you potentially could gang even more up and make more bends at the same time. So take a look at this. Okay, so that was relatively thick material. Fairly small parts, thick material. This is a little bit longer part, thinner material, and maybe a little bit wider channel. So you'll notice the ejection pad here. I'll run that back just a little bit, but this particular tool had an ejector so that the part doesn't stick in the channel. Okay. Another type of channel tool, you could potentially have a rotary bender, so the colorful drawing that you see, you're still making it in one hit. And you've got a little, we're going to call them a Pac-Man or a rotary type of insert that'll come down and it'll actually wipe the part into place rather than dragging it over the shoulder of a die again. So a good thing to reduce your tonnage, reduces some marking, helps hold distortion. And you can also see there's a little pad on the bottom to help keep that flat. So that would be a common rotary type of channel tool. On the right-hand side where it says video, here you're seeing another form of a rotary tool. And this one's going to probably prevent more of a whip-up action from the material. You can take a 4x8 sheet of material, make a bend, make another bend, and the sheet won't move. So I'll show you another quick video here. So you notice the sheet's not moving at all. It's in place, and this is a fairly short bend that we're making. It's not a big piece of material, but you can imagine in your shop or any shop that you've seen that material that the operator's holding on to be whipping way up over his head potentially if it's big enough. And that tool is able to keep the material in place, and you don't get the whip up action. So real common type of channel. It's called a channel tool, but you're really single hitting in that particular case. Look at a curl tool. Pretty common tool to make actually. A lot of these hinges or knuckles that people are trying to make on material aren't able to be made in a punch press. It's too thick of material, maybe the hinge is too long, maybe you don't have a punch press. A lot of lasers out there. So if you've moved towards that laser world and you're having a difficult time forming, and the only thing you need to do is make a hinge, potentially you're buying something for the press brake these days. So you can see on the top right picture, that's really thick material. That's 1/4 inch material. And it was made in a press brake with a two-stage operation like I'll show you in the video next. The picture below is 060 material. So any range of material, any length, up to the length of the press brake. The only thing really limiting you is the length of your press brake and the tonnage capacity in that brake. You will notice that there's a flat. Put arrows on there describing the flat. It's not a complete 360-degree round. You get that flat portion on there when you do it in the press brake. So in the turret, you could make that a full diameter, a little bit different than the press brake. But generally, by the time you get to the press brake, that's not as big an issue as whether it can actually operate as a hinge. So let me show you. You're going to see the first video is going to be a preform. So we're going to hit this, make 2 bends, and get it ready to fold it over. So there you have your, hard to see with that arrow, but you've got your form made, so it's ready to be curled over now. And I'm going to show you that one more time because people like to see this curl over. This is where heat treat becomes important in a tool as well, because as this flange on the top that's on the end of the bend curls over, it's also scraping inside the tool. So if you make a tool like this and it's not heat treated properly, you probably won't get real good wear life or repeatability out of it. All right, that's oops. Next tool will be a gusset tool. A gusset, we're going to talk, is just a stiffening rib, so it's going to add strength to something. And you see this really common in any type of material that's going to have, it's maybe thin material, it could be thick material, anything for strength, light fixtures, heavy brackets, almost anything. And if you go to have this made and you want to make something just as a stiffener, but the diameter isn't that important, it really helps out when you're designing the tool because you really aren't concerned about radius now. You're just concerned about stiffness. As soon as you start dialing in that tolerance on the gusset, generally from any supplier, the price is going to go up a little bit because now it has to be tested and has to make sure to make your particular diameter or radius. So the less called out, the better if it's just a crude stiffener. And we do have a video of this as well. Okay, so before the video starts, what you're seeing is on the top portion, you have a punch that's been relieved to the diameter of the pin, accounting for the material thickness as well. So, and on the bottom, there are 2 pins pushed into the die so that the punch can form around the pins. Okay. One thing to note here is if you did have something like this made up and you had a need for gussets, but the gussets aren't always in the same place along the length of the bend every single time, and you want to be able to move that gusset, those pins can be put into smaller pieces of tooling, and then you just use sectionalized tooling to locate your gusset. So you don't have to build it into a solid length. You could actually make little pieces that are gusset pieces. That works well. Okay, and there's another question I just wanted to ask everyone. If you could take this poll, you can start answering at any time, but really you have 3 choices and then you have a combination of choices of what's going on. What do you consider when ordering a special tool? You contact Wilson Tool or any other supplier, and what's driving your purchase? Is it price? Is it delivery? Is it quality of form? Or is it a combination? There are combination choices. 4, 5, 6 are combinations of 1, 2, 3. So price and delivery, is it a combination of price and delivery? Is it quality? By the time we see, I can tell you, a lot of people that come to us, and at our particular White Bear Lake plant, you come to us because you've been making it already and the quality of the form is very important to you. So I could see a combination answer here. Okay, you should see the poll. And of course, you could pick all the above. But if there's 2 that drive or 1 that drives even more than all of them combined, let us know that. Here again, I've got a prediction on this, but it's a little harder because I put the combination choices in there, so it might water down a little bit.
Thank you.
We've got a few more seconds here, so if you can put in your answer. And okay, so we've got our answers. You guys, half of you picked all of the above. So they are all important, and they are to us as well when we supply tools. But I was predicting that price and delivery would be very high, and that came in at 15%. So it's actually a little lower than I thought. Choice, price, and quality of form was actually 30%. So that was the next highest. No one selected price only, and no one selected quality only. Looks like maybe 1 or 2 people picked delivery only. So thank you for that information. That is actually something that we listen to. Those are the 3 buzz points that we listen to a lot. So getting back to the different categories that we're talking about, just heavier bending of material. And I'm going to say 1/2 inch or thicker, but, you know, I think to the average person, thick material might even be 1/4 inch or somewhere a little bit lighter than 1/2 inch. But for sake of in the dies that I'm going to show you, let's say it's 1/2 inch. These are I'm going to show you these adjustable dies. They're high tensile strength. They're meant to take tonnage and abuse, basically, because you can see all of these designs. In the upper left, you'll see the adjustable with shim. The whole idea here is you've got a steel body probably, and each one of those lines that you see, those vertical lines, are representing a shim and the bolt that holds on to the shim. So as you change this die opening, you're actually unbolting and pulling out steel shims most of the time, and you put the steel shim back in when you want to, you know, decrease the size of the bee. So in and out of long, heavy shims. It just works. It's been a traditional way to change the opening of a die without rebuying a die each time. You probably don't have a lot of setups because this is very setup intensive. In the bottom left, you see the colorful green drawing. This is an adjustable die that you can see bolt heads on the top of each one of those shoulders. If you loosen up that bolt head, it's spring loaded. It pushes the insert up, the whole shoulder insert, and then you see teeth on the bottom of that base. It allows you to move the shoulder inserts left or right to open up or close up the opening size. On the top of this design, you've got a dowel. That dowel can be virtually any material that we want it to be or you want it to be. So we'll probably put something very durable in there, a hardened rod. And now that abusive material that is constantly dragging over it, next time you go to replace your rod, you don't have to replace the entire body. You're replacing the wear point. So that makes a lot of sense. You bend a lot of heavy plate. On the right-hand side, on the lower right, you see the exact, it's a live picture of the CAD drawing that you see in the green color. In the upper right-hand corner, this is the same concept. You have the insertable shoulder, and it might even move a little bit while you bend, which helps reduce friction. But for the most part, it's something that's just, you can take it out, you can replace it. But it's a fixed type of die. You don't see the ability to adjust that one. So it's really 3 different concepts to achieve the same thing. Probably more efficiency in the lower left or the bottom portion of this picture, and great durability in all 3 of these. If you've been on our website, you might have seen this video. It's actually a video showing you the adjustable die, and I'm going to set it up a little bit because what I just showed you was manual. Everything was manual. You unscrewed the top, you let it pop up, you can move it in and out. What the video shows you is that it's a die that's adjustable. There are no wrenches or anything manual to do because it's going to be a pneumatic hydraulic combination, and that's what's going to lift the die up and move the die in and out. So it's an NC control that you're going to see at the start of the video, and you wonder why we're showing you that. Really just showing you that it's NC controlled. You're going to adjust the die, and then the die is going to go do whatever you tell it to do. So let me show you this video. It makes sense when you see it. All right, and here's the control I was talking about. Don't get too wrapped up in the detail. I don't know how to use this myself, but you're going to put in parameters, and you're going to let the die do its work. So I'll start and stop this a little bit and walk through it. Okay, so the die has been controlled. You punched in your control. You're seeing a manifold. Let's go back just a little bit. Seeing a manifold here, and that is your hydraulic line going into the die. Right there, that's your manifold. It zoomed in on the teeth that it lifted up the whole shoulder, and now it's moving the die into position. You can see there's a baffle in between the two shoulders to keep debris out. It's settling back down now. What you're seeing here, I'm going to pause this because look in the bottom of the die and you'll see some rollers popping up and receding. And what that's showing you is you're able to open up this die, put a regular die into this holder from one end and slide it right in. So those are meant to be rollers to throw an existing die in there. And you can use this as a die holder. That's why you see that slot down the middle of the holder. So it's pretty versatile. It's a big behemoth to take in and out of your brake. So this is something that you're going to buy and you're probably going to leave it in there. And as you leave it in there, you might want to use other tooling and you can use it. It'd still have to be pretty big tooling because you'd have to control how tall the die is relative to the inserts, but it gives you that ability. Okay. Okay, let's move on here. There's another hemming solution. If you have a lot of hemming going on, you're probably going to be looking at this. You've already got, maybe be familiar with a two-stage hemming die. Like in step one that you see in this slide, you're going to put your material on the top of the V, you're going to make your 30-degree bend. In step two, you're going to put it into the jaw and it's going to flatten it. This can be all one piece in your 10-foot press brake, so it's one handling rather than two. So I think a lot of people are hep on the idea of one piece handling when you're making that hem. But now if you were to go and just look at this, we've added a pneumatic feature to it. So the pneumatic will actually move it up and down. What you're really seeing though is when it goes down, we're letting the air out. And I'm going to show you a video of this, but the punch is going to actuate the bending on the downward stroke, and the air is pushing the die back up. And you wonder what's the difference? You could buy the spring load, and you could. The springs would work well too, but you'll see the air gives a quick retract, and it goes to the same point every single time. So it made more of a positive stop. So if you do a lot of hemming, this is who buys this tool. You don't buy this if you do it occasionally. Okay, let's go to. Okay, and so you're seeing the air is pushing it up, and when we let the air out, it goes back down. But your retract is positive. It goes back every single time and relatively quick, whereas a spring might be a little bit more wobbly and lazy, and it goes to about the same place every time. Works really well most of the time, but your heavy hemming operation, you might buy one of these pneumatic styles.
Your audio went out.
Okay. A couple other hemming options. If you ever had a hem that's in the middle of a sheet, for lack of a better term, you can send us a note if you have a name for this. We call it a standing mid-sheet hem. Pretty much describes what it is. But in step one on the left-hand side, you're making a form, you're making 3 bends at the same time. And on step 2, it's just a wedge system. We're going to put that pre-bend, pre-form into the step 2. As we push down, the wedge system comes together and it makes a seam right in the middle of the part. So not an uncommon tool, but tell me what you guys call it. You can email that over if you've got an actual name for that. But on the right-hand side, it's just an open hem. So in step 1, here again, we're making the pre-form, we're making 3 bends. We're going to slide that over into actually there's 2 bends. It's more of like an acute offset. We're going to take that, slide it over on the right-hand side, and it doesn't show real well, but there's a shim in there. There's a built-in shim built into that back gauge that you see. And it comes down, and it hems right onto the shim. You may or may not really need the shim because you can also see on the left-hand side of that punch, there's a little concave that we're putting into the punch, so it comes down and hits a positive point so we don't crush the hem. So for those of you, ironically, I just talked to somebody yesterday and they asked about that exact tool. And it's not uncommon to want something that's about a material thickness, opened up and not crushed and not a teardrop. So that's how you would do it. Louver tools, you can take these direct from the laser right into the press brake. So here again, we're talking about lasers because if you don't have a punch press, you can't make a louver in a laser. So it might push it over to the press brake. You know, you might have a louver that's long. You want to make it all in one hit. You might have a louver that's it's the only form. It's the only thing that you do that you would need a punch press for you. So you don't want to put it in the punch press just for the louver. You want to put it in the press brake maybe. Maybe your volume isn't that high. You're probably not putting this in the press brake as a first choice, unless it's too long or it's too tall or it's too something for the punch press. A punch press is going to do a louver, I don't know if I have a number on it, 60 times faster, a lot faster, if it's already in the punch press. But for all these different reasons, you might want to do a louver. And it works well, and I'm going to show you a video, but what you're going to see on this video is you're going to see what we'll call snap through. So there's two different ways to make a louver in a press brake. If you already had it in the punch press or the laser, you could slit the material so that the form can just happen. Or when it's in the press brake, you can slit the material or pierce it, and then you can form it. But when you pierce this, you're going to want to check with your brake manufacturer because there aren't many out there that I'm aware of that account for the snap through in their press brake. It gets transferred into the hydraulics, even if we use spring pressure to try to absorb some of it. So that snap through that goes into your hydraulics, if you did it once or twice, it's not a big deal. But over time, if you do it repetitively, you could have problems. So you probably want to check that out. When you give that spiel to somebody, the next thing is they say, I don't really need to do that. I don't need to pierce it. I just need to form it because I already have it in my punch press with laser. So you can do it either way, though. We can make a tool. That's not the issue. Just be conscious of what you're doing to your press brake with any kind of volume. So let me show you the louver video. And like I say, what you're going to see here is just a blank sheet. We didn't show that to you ahead of time or anything, but it's going to pierce the material, and it's also going to form it. Nice, big, tall louver. This is a good press brake application. You wouldn't be able to do this in most punch presses, I don't think. And now what you're going to see is the second louver being put in, so we can gang louvers up as well. Okay, radius bending is a nice big radius. And I think anyone that's done any kind of bending knows about what's going to happen here. It's going to relax and your radius is going to grow. So we'll take that requirement from the customer. You have your requirement of either to make a radius tool to a specific radius, or you want to make a finished radius with a particular radius call out that'll take some testing. So this particular one obviously is big, and we had to make the tool and then rework the tool once or twice just to get it to relax into the radius that the customer wanted. So I'll show you this, and just watch for the spring back. You get a great amount of spring back. The bigger the radius, the more tensile strength in the material, the more spring back you're going to get. Watch the spring back here. It's a lot of spring back. So if you start out with, let's just call that for conversation, it's a 2-inch radius, 2.5-inch radius. You don't end up with a 2.5-inch radius after you bend. So as you're calculating out how big your tool needs to be and you're sending requirements to tooling companies, just make sure you account for that spring back so your finished form is what you want it to be. lot of spring back there. And of course, you can do some radius bending with multiple radiuses. This particular light fixture that we made a tool for is a combination of different radiuses. Those aren't all the same radius blended there. They're different radiuses. And you'd probably guess that's for a dentist chair. It's probably a light reflector for a dentist chair, something close to that. But this is something, not only did you need to have the right radius blended the right way at the right angle, it also couldn't have any marking to it. So a lot of different reasons to make a special tool here. It'd be really difficult to make this. This part was being made with standard tooling as a prototype, just to prove that they could do it, but was not even close to being acceptable to the end customer. So it needed something a little bit different. And our last and final question, go ahead and answer here. And on a normal day, and I put normal because everybody has things outside of normal and you might need it even quicker. But when do you expect to get your quote back from a vendor? If you send it to us or any other tool supplier, would you be happy with a half a day most of the time, 1 day, 1.5, 2 days? Within 3 or 4 days. And I'm going to just go on a limb and say most of you aren't going to say 3 or 4 days, but as a big project, maybe you do have that. Maybe you run ahead of time and you do a very good job planning and you're not a job shop, so that very well could be. So if you could answer that. Here again, I probably have a little bit of a preconceived notion of what you're going to say, but it could be a couple different answers. Just a few more seconds if you can cast your ballot. Okay, oh, wow, it really split. We have 20% of you say that you'd like to have it within a half a day, another 20% 1 day, 24% in a day and a half, 24% in 2 days, and 8% in 3 to 4 days. And I would guess those people that are 8%ers, you probably are more of a, you've got a product line that you're able to plan a little bit more. I would guess the people that need it in a half a day or 1 day, you're probably a job shop and it came to you, and if you don't get your quote, you don't get your job. So we get that, and that all makes sense. Thank you again for the information. Just a couple more slides here, but the embossed letter stamp character, just the idea that you can stamp inside your press brake. The only limiting factors here, again, are probably going to be not so much length. We don't usually see a 10-foot emboss because you don't have tonnage to do that. So we have to calculate the square inch, the tonnage being generated, match that up to your machine. On the right-hand side, though, you see a letter stamp character with replaceable characters. It's the same punch holder that you'd see in any kind of press brake that's been adapted to use the characters that are sold in our punch division. So you can interchange those characters. There's a little pin that just holds your characters in, just like in punching. So it's a total copy of punching into the press brake world, and you can get that in any style tool, of course. Card guide, this is our last one. I want to show you a card guide because here again, a real common punch press item, and you'd probably do in the punch press unless there's some other reason not to. So we'll show you this video quick. You'll notice each one of these are there's a pin for a locator, so you're not using the back gauge. You can also see that it's very slow. So here again, you'd be making this in a press brake because you need to for some other reason other than speed. And the final slide we have here is just showing you that we do make, and I think it's getting more and more common to see some sort of holder that holds your punch tooling. So here again, you don't put it in the punch press for any other reason. Maybe you bought a laser and you haven't rebought, you just don't have a way to form, but you want to do it in the press brake. You can use some of your punch tooling with the correct holders to adapt over that tooling into the press brake. So here again, 10 years ago, we didn't get asked for this at all. In the last 5 years, we start getting asked for this quite a bit. So people are getting creative and using existing tooling. And we'll open it up for questions and answers. If you have any kind of questions, just send those over to us. And we do have a couple from along the way here. So let me just read through these quick. Do you experience binding of the forming material around the shim when using that type of open hem? Okay, open hem. So that's probably the, let's see if I can go back. I think you're referring to the second step on the right-hand side here. So, no, I don't know that we get a lot of binding. That hasn't been an issue with that type of tool. If you were to put a spacer in there though, and you're hemming over the spacer, potentially you're going to have that spacer stick. So if we put a spacer in a tool, generally what we'll do is we'll fix it to the tool in some way so that when you pull on it, you can pull it out and it doesn't come with the tool. So in the manual crude method you're probably using before you buy something that's a little more slick and streamlined, is you're taking a piece of material and you're putting it in there, and the longer it is, the more you hem over it, the more it sticks, and now you have to find a way to get the spacer out of the hem. So that becomes more of a challenge than actually making a space. So we will put something in there that's more fixed so that you can remove it from the material. But no, I don't know that we've experienced a lot of binding issues with that particular design. Hopefully I answered the question there. Another question, do you have a spring back chart compiled as a reference for large radius bending calculation, or do we rely on the quote process going through your engineers to determine what's needed? Really good question. If we had a spring back chart, if I could make one of those spring back charts, I think there's a really good chance I could make money, because every single material, combined with every single radius and angle, combined with finish, controls what we're going to do with that tool, the design of the tool, and how much it's going to spring back. So I think we have internally come up with some ideas and guidelines, but I don't know if they're really to the point where we'd publish them and then you'd go by it and start using it, because then it might not be quite right. Because our main driver to get this right is going to be to take your material, put it in that tool after we make it, test it, and rework it and get it back to where it needs to be so it's perfect within your tolerance, at least for what you called out. So no, we don't really have anything. It is part of the quoting process. When you see the quote come back from us, what we'll do is we're going to account for what you called out as a tolerance in a finished form, and we'll build that into the testing. So generally, testing is not, we probably put more of a flat charge on testing than specific to what you do, unless the tolerance is so tight that we know that we're going to spend a lot of time reworking it. Those are the questions. We just had a couple questions. So hopefully you're able to take away one thing from the seminar. One idea might have spurred a thought, but if you have any other questions, let me know. You'll have our contact information here. Thank you.